Okay, so this was something from Wolfram Demonstration Project, and it allows you to just make an interactive map. So why don't you come around and move the mouse and play with this and see some things that you think are interesting.
So, let's see. Move out, it seems.
Actually, change the 100% down there to 150%. Let's zoom in a little bit. That'll show up better.
Yeah. So, we zoom out like this, and then...
This probably has the bottom labeled correctly, as opposed to mine.
Continue to zoom out. And it still seems to like slope upward.
Okay, so hold on, leave it there. Tell me about some things you notice here.
So, it seems to go up like steeper at the beginning.
Okay.
And then it seems to like go up at a constant rate. And then it seems like this seems to be like disintegrated. The top arc seems to be like disintegrating or some. It's getting more faint while this one is just staying the same.
Alright, what do you notice?
The top arc they're both steep at first and then constant, it looks like. But the top arc's just steeper.
What do you mean constant?
Like, it seems like there's like a curve at the beginning, like till maybe like 1,000 or so.
Mm-hmm.
And then it seems to more now look like a straight line.
I see. So it's not constant, but it's a straight line.
It has a constant slope.
It looks like it has a constant slope. Okay, and remember what David Eisenbud said about the number of these is going to look like n over log n squared. But log n itself is not moving very quickly.
Yeah.
So you might be right. It might have a constant slope. But the tricky thing is that log n squared that he was talking about on the bottom isn't changing very much. So when you look from, say, 3,000 to 4,000, it looks sort of like the bottom is the same number. All right?
We'll go up.
So go up to 10,000. I think that's the largest I allowed this to be. All right, yeah, go there. Let's talk about what we see now. Well, hold on. Let it calculate. Okay. So what are you seeing here?
Well, it still seems to be constant, and it seems like the top arc here is sort of thinning out a little, and there's like some loose stuff on the top.
All right, what do you see?
I'm seeing like these two bands. Now it looks more like 4 arcs. There's like these 2 thick ones that you can see.
Uh-huh.
And then there's this thinner one that sort of makes this border. And then a thinner one down here. But there's nothing in between the 2 arc
There's
sets.
nothing below, too.
Yeah, that's actually really surprising. So, if we could figure out how to describe these arcs, I mean, I sort of see one at the bottom, one right here.
Yeah.
And there's a faint one kind of even a little bit above that. You see that one?
Yep.
Yes.
If we could figure out how to describe those, it might be just as hard of a problem to find why there's none in the middle as to why there's none down here.
Yeah.
I mean, it's actually fairly easy to understand why there's no dot up here. Like, why is there, for 2,000, why are there not 300 ways to...
Well, there's
There's not
doubt there's even 300 primes.
Right, there might not be 300 primes. And if there are 300 primes less than 2,000, we could just change it to 500. Why aren't there 500 ways to do
Yeah.
it? That's easy to see.
But seeing like why there's none with like 50, basically like around 8,000, or even like 25.
Yeah.
I mean,
Or up in here, so like 100. So around 6,000, there just seems to be no way to do it with 100. But there like maybe at 120, there are a bunch of ways to do it, and below it. So that's actually kind of an interesting surprise. I didn't know that. I had never heard of this Goldbach comment before. Anything else you think is surprising here?
No, not really.
No.
Okay. All right. Good job this morning, guys.